Today we're going to go through calibrating some different types of spray equipment, and we're going to first focus on what product we're going to use. And to know what product we can use, we have to know what equipment we have. If that product is compatible with our equipment, we need to know our site meaning where we're going to apply or the crop it will be applied on. In this case today, we will use the section for tropical and subtropical trees and fruits, and we'll pretend that we're in an avocado orchard. We'll need to know several different things in the label. We're going to need to know the rates for our pest, which will be sandburr at 4 inches. We'll look through the table in the label on that. We'll go through the equipment information and restrictions around what equipment we can use so that we know we have compatible equipment. We'll also go through some environmental considerations, PPE requirements, and agricultural use requirements. As we're looking at this label for Honcho Plus, we can refer to page 63. In section 10.8, we see our site listed. Site meaning crop in this case. It is tropical and subtropical trees and fruits, and it gives us the labeled crops. This is an exclusive list, so anything outside of this, we cannot use it. But we decided we're going to use this for avocado, which is listed on the label. We know in our established avocado orchard that we have an issue with the weed sandburr, which is what we're going to try to manage and why we're calibrating our equipment today. So on page 115 of the Honcho Plus label, we see the annual weeds rate section, where we'll know if this product will be effective against the weed that we're trying to treat or not, and some conditions. So if we locate sandburr on page 115, and we see the maximum height of 4 inches is what we decided. It's under 16 inches, so that's the first column. And that gives us a rate of 6 ounces per acre. On page 7, in the physical or chemical hazards section, in section 3.3, we can see some equipment requirements that we need to meet. It states, spray solutions of this product may be mixed, stored, and applied using only stainless steel, fiberglass, plastic, or plastic-lined steel containers. It also says that this product cannot be used with galvanized or unlined steel containers or spray tanks. This product or spray solutions of this product react with such containers and tanks to produce hydrogen gas, which may form a highly combustible gas mixture. This gas mixture could flow or explode, causing serious personal injury if ignited by open flame, spark, welder's torch, lighted cigarette, or other ignition source. So we know from our spray equipment, we're using plastic tanks, and some fittings that require metal are stainless steel. On page 10, we can see the product information. It says that this is a water-soluble liquid. It can be applied using most standard industrial or field sprayers after dilution and thoroughly mixing with water or other carriers according to label directions. So we know that with our application equipment, we won't need agitation as we would with a formulation such as wettable powders. Our equipment that we have with the ATV boom sprayer and a backpack sprayer will work with this product. On page 6, we see relevant information on what kind of PPE is required for use in mixing with this product. So applicators and other handlers, so this would mean including mixing or transporting this opened container, will require long-sleeved shirt and long pants, plus shoes, plus socks, and protective eyewear. In this case today, because I will be using a backpack sprayer, I want a bit more protection, which is allowable in the law. So I will be using chemical-resistant boots and chemical-resistant coveralls. It is always allowable to have more personal protective equipment than required by the label, but never less than what the label requires. On page 7, the environmental hazards section, we need to note Do not apply directly to water, to areas where surface water is present or intertidal areas below the mean high water mark. Do not contaminate water when cleaning equipment or disposing of equipment wash waters. Our farm is not in a waterway, so we're fine. On page 15, there is a note that this product works best with volume rates of at least 10 gallons per acre of carrier, but it is not a requirement. Also, on page 15 and 16, we have the tank mixing procedure. Prepare tank mixtures of this product as follows. Place a 10 to 35 mesh screen or wetting basket over the filling port of the tank. Through the screen, fill the tank 1/2 full with water and start gentle agitation. Continue filling the tank with water through the screen and add the required amount of water of this product near the end of the filling process. If a non-ionic surfactant is used, add it to the tank before completing the filling process. Add individual formulations to the spray tank as follows. Wettable powders, flowables, emulsifiable concentrates, drift control additives, water-soluble liquids, which is this product if you remember, and surfactants. In this case, we'll just be using this product only. Maintain gentle agitations at all times until the contents of the tank are sprayed out. If the mixture is allowed to settle through the agitation, may be required to resuspend the mixture before spraying. Keep bypass and return lines near or at the bottom of the tank to minimize foaming. Screen size in nozzles or line strainers can be no finer than 50 mesh. In this case, if we need to agitate our backpack sprayer, we can just shake it, as this is a water-soluble formulation, and we should get enough agitation from ATV boom sprayer by driving over rough terrain. If not, we can continue to mix by using the sprayer tip and the pump running into the tank. On page 8, there's an agricultural use requirements box in the direction for use section. It states the REI, restricted entry interval, for entering into this field without the proper PPE for anybody, which is 12 hours. So after application, nobody can enter the field without the same PPE within 12 hours. Since we're doing an agricultural operation here in an avocado field, we will need to follow these rules. Because it's an agricultural use, we also need to comply with the expanded PPE rules, which require coveralls, chemical-resistant gloves of greater than 14 mils in thickness, composed of materials such as butyl rubber, natural rubber, neoprene rubber, or nitrile rubber, shoes plus socks, and protective eyewear. Today we're going to be doing some of the volume over time, part of the calibration. I'm wearing PPE now. Even though for this part of calibration, you should just be doing it with water so you understand. However, because we're getting into good practice of wearing PPE during our pesticide applications, I want to demo how to be safe. Our label states we need chemical resistant gloves. It does not state what kind, so category A is fine. Nitrile, more than 14 inches. We have eye protection also on the label. And we have coveralls, and because I don't want to get my shirt and pants dirty, it just requires long pants and long shirt, shoes and socks, but I want to be able to take off this Tyvek suit and be clean and safe. I have chemical resistant footwear as well. It's extra compared to what's on the label, but since we're dealing with a liquid and my shoes can absorb liquids, I feel like this is safer. Always, you can add more PPE than the label requires, but not less. Okay, for volume over time, so we understand the output of our sprayer. On a boom sprayer, we have 4 nozzles. So we're gonna collect the output from 4 nozzles, make sure that they're all the same output for each nozzle, and then add the volumes together. And that's how we know how many gallons per minute we are applying. So my friend Jensen over here is gonna help me put a timer on for 1 minute, because I don't want to be touching my phone when I have possible contamination on my hands. Now we're gonna verify that all of our containers have the same amount of water so that we know that there's no blockages. They look the same to me, so let's consolidate them. It's good to keep your PPE on even if you're just running water, because we can assume that any equipment that has had pesticides run through it may still have some residual and be contaminated. We can see that we are at 170 ounces. So I need some help here with math. Can someone divide 170 by 128? Because there's 128 fluid ounces per gallon. So we have 1.33 gallons per minute coming out of this boom with this pump at this setting. So we have now volume over time, gallons per minute. The next step, we will do distance over time. And that will help us to understand how much area we're getting in 1 minute and 1.3 gallons. Now we'll show how to do distance over time. To help me, we have Jensen Ueda, Extension Agent at the University of Hawaii at Manoa. So we will first measure out 100 feet, as this is an easy unit to multiply. Jensen, can you help me hold this? Okay, here we have 100 feet. We will now run our equipment over this distance of 100 feet and time how long it takes to get here. Now for distance over time with the ATV boom sprayer, we will get a stopwatch and time how long it takes Jensen to drive the ATV at a consistent rate, 100 feet. Usually we'll do this 3 times and average the times of all 3 passes. So I'll give Jensen the signal when he's ready, and then we can go. The rate that Jensen is driving should be the same as the rate he will use when he's applying pesticides. We have 18.2 seconds. Now that we've finished timing the distance and averaging, we have an average of 18 seconds for 100 feet with this ATV at a consistent speed of 2 to 3 miles per hour. We will now measure the swath. The swath means the length of the spray minus the overlap. So if you remember, we have overlap of 20 to 30% per nozzle. That means we'll measure the outside of where the water reaches and then cut off that 20% on each side, which we'll cover with our next pass. From this, we'll be able to calculate area. We'll have the width by the length of 100 feet. Then we can convert to acres. So I'll turn on the pump and we will be able to measure. So we have 0 over here and the water is just reaching 0. So I'll move it up a little bit to compensate for that overlap. So we have exactly 6 feet for our swath. We have 6 feet here. Remember, we have a little bit extra, 20% on either side, that we'll do with our next pass. We'll overlap with our next pass. So we have a 6-foot swath. Then so we have 6 times 100. That's 600 square feet that we are able to pass in an average of 18 seconds with this ATV. Now we have distance over time. So distance over time plus volume over time, we know our output from our sprayer and we can calculate the rate that we spray. Next we'll do the backpack sprayer distance, same like we did with the ATV boom sprayer. Jensen will take time from me as I walk at my pace that I will be walking when I spray. So I will practice with water to make sure I get my swath and good coverage as I walk this distance. So let's start. I'm making sure there's no bare ground. As if this is a real herbicide application, I want good coverage. I'm also wearing more PPE than the label requires because I'm walking through this spray and I do not want any herbicide absorbing into my regular shoes. So I'm wearing chemical resistant boots. It's important to try to keep the nozzle at the same height and in the same orientation as you go. This will ensure consistent coverage. It's good to keep in mind that because we're using clean equipment here, I'm able to spray clean water on this measuring tape. But if you have equipment that's been used with pesticides before, either you're going to have to rinse your measuring tape, or you can use flags to flag out that 100 feet. Now we'll do this 2 more times in average. To do swath for a backpack sprayer, we need to make our pattern as if we were spraying for real, and then measure the width. Here we have asphalt where it's quite easy to see the water in contrast with the dry asphalt. So I'll make a spray pattern in the same way I did when I did the distance over time. Note that the coverage is leaving little bare earth. It's mostly wet. Okay, now we can measure the swath. So I'll measure from edge to edge. And we have 5 feet and 6 inches swath. So the width of the spray, 5 feet and 6 inches. Now we can calculate area, 100 feet by 5 feet and 6 inches. For the other part of doing the calibrations for a backpack sprayer, we will do volume over time. This is the same concept as with the ATV boom sprayer, but we have only one nozzle here. That's it. So we don't need to pour together to add all of them. So Jensen, you can take time for me. Okay, 1, 2, 3, go. So now we finished our 1 minute of filling this for volume over time. We ended up with 55 ounces, 55 fluid ounces. So we need to calculate our gallons per minute, right? If you remember, we did 1 minute. 1 gallon is 128 fluid ounces. We got 55, so it's just under half of a gallon, 0.42 gallons per minute with this backpack sprayer. Then we'll be able to calculate our rates and our output from our sprayers per acre, and we'll do that in just a moment. Now that we've done some work in the field, we get to do some math. So we'll be working on the numbers from the ATV boom sprayer, but we can substitute all of these with the backpack sprayer numbers as well. So we know our spray area already. We measured a length of 100 feet, and we know our boom width is 6 feet. If we wanted to, we could change this out for our backpack sprayer swath, which was 5 feet and 6 inches if we wanted to. But for now, we're just gonna keep with the ATV numbers. Okay, so length times width, we know we measured 600 square feet. Now, because we measured separately, we did 1 minute to get an adequate volume of water for us to measure inside of the measuring cup. We measured 1 minute and we got 1.3 gallons. To get that into the same units and the same area as we did for the spray area, we're gonna have to do a little bit of math. It took us 18 seconds to cover that 600 square feet. So what we have to do is look at this 1.3 gallons per minute. Remember, 1 minute is 60 seconds. So that gives us 0.022 gallons per second. Then we multiply by 18, and that gives us 0.4 gallons over that 600 square feet. We could also measure the time for 600 square feet, which is 18 seconds, and then measure the boom output for 18 seconds. However, in this case, we did it the other way, so we would have more volume to measure and more accurate. Now, we have to factor in the size of our field, so we know how many gallons of solution we'll be spraying over our field. Because our label we're working with today does not have a carrier limit or carrier volume expressed in the label, so we can use exactly the output from our ATV now. Our field size here will be 10,000 square feet, and so we have to do some more math. We have 0.4 gallons for 600 square feet. We divide this and then multiply by 10,000 to get the size of our field. And then we'll end up with 6.7 gallons of solution for our field. So we know our field is 10,000 square feet, and we read the label earlier, and we're gonna spray sandbur in the labeled rate for our 4 inches of sandbur that we decided that we needed to spray is 6 ounces per acre. So we have a bit more math to do to get to our field, the ounces for our field of 10,000 square feet. So we know 6 ounces, 1 acre. 1 acre is 43,560 square feet. Then we're gonna multiply by our field size, and we're gonna end up with 1.4 fluid ounces of product for our 10,000 square foot field. Remember that if we wanted to do this for the backpack sprayer, we would change some numbers with the boom width. We would also change the number of the output, so gallons per second. And if our field size changed, we would change those numbers. And finally, if we had a different size of sandbur or a different weed that we were trying to manage, our rate might be different as well. So you can use this general formula and just change the numbers anytime you need to. Why we do this process of calibration before we spray, there's several reasons that this is really important for us to do. The first and foremost is safety for you, for the environment. Make sure we're not over applying pesticides. Also, for efficacy, we want to make sure that you're not under applying, right? You have enough to be effective at whatever management you're trying to do. In this case, sandbur. You want to make sure the sandbur is managed, it's dead. If we under apply, that might not happen. And if we under apply, we also risk creating resistant populations of the sandbur. So we want to apply at the full label rate, not above, not below. This is also important for compliance purposes. You know, it is the law, right, that you cannot over apply. So we want to really stress that as well. In addition to not having excess hazardous waste and things like that, you know, you'll save money by using the right amount of pesticide when you mix and apply. If you have waste, right, you're wasting money, and also you need to spend money to get rid of that hazardous waste. So it's quite important to be applying the right amount. It's also important to note it's not good to store mixed pesticides in a tank. For example, if you finish your spray today and you want to spray more maybe next month, if you leave it in the tank, whatever the product is could precipitate, could block your nozzles, it could gunk up your tank. Also, it creates a lot of issues. You know, you're gonna have to continuously agitate it. So it's best to use only what you need when you need it and use the full amount. You don't want to store mixed pesticides in your tank. Many things could happen, right? It could gunk up your stuff, or it could precipitate, volatilize, degrade over time, and then you don't know what you're working with by the time you apply it again. And finally, we want to minimize waste. We don't want to be done spraying our fields at the rate that we want and then have excess hazardous material in a tank that we have to dispose of. So it's really important to spray out your whole tank as you're applying on your field to have the right amount. Now we're ready to mix our tanks. To do this, we did some math with how long it took for me to do distance over time, and then we did volume over time. Because walking was a lot slower than the ATV backpack sprayer, we'll be having different ratios of water to product. So we will end up doing 4 full backpack sprayers, 4 gallons each in this tank, and then 1 additional partially filled tank of 2.7 gallons. The first 4 tanks will have 9 mLs of product mixed with those 4 gallons of water, and the final tank will have 6 mLs of product mixed in the final tank. Now I'll demonstrate how to fill the tank properly. So we're gonna put our mesh filter in the tank as indicated by the label. Then we're gonna keep an air gap from the hose to the tank as we fill the tank halfway full. You see this gap between the tip of the hose and the tank? This means there will be no back siphoning of product into the clean water source. Okay, now we have the tank halfway full. This is where you would add any other products that you would like to add to the tank mix. In this case, we won't add any other products, and the label indicates to fill to almost full and then add this product. However, you could potentially use other products which you would mix now. Also, fertilizers are a common product to add to help with uptake. So you would do that now with half full. Okay, so we're gonna continue to fill to almost full and then mix our product. Now our tank is almost full. So as indicated by the label, we'll now apply our product into the tank. Remember, you keep this mesh in the tank as you add the product. Okay, for the purposes of this demonstration, we will use water, not real product. And we have a pipette here that will be able to measure out 9 mLs for the first 4 tanks. So I have 9 mLs of product here that I'm going to add through the mesh into the tank. Okay, then to make sure that my pipette is clean or we're getting all the product out, I'm going to take some water, put back in, take some water, put back in, and then we'll use this pipette for later as well. Be careful not to contaminate all your supplies, so I'm putting it back in the original bag. Okay. Then we'll add a little bit more water at a very slow flow rate to top off the tank. Now our tank is full, and we want to make sure that the product mixes in the tank very well. Now I'm going to agitate with the wand because we know that this wand will be contaminated with pesticides through the application anyways. So I'm going to take off the mesh. I'm going to put it on our mixing pad, which is used for collecting water associated with pesticide mixing anyways, which we will apply out later in a manner consistent with the labeling. So this is going here, and I'll start to agitate. Please note that if you need to re-agitate while you're applying, you can always put the wand back inside and agitate again, even if the tank is halfway empty. Sometimes the pesticide formulation will settle over time, so you may need to re-agitate as you go. Remember, for our final tank that we'll be mixing today, we'll have 2.7 gallons. So anytime you or I mix a partial tank, we need to pay close attention to the tank capacity and how full it is. So our final tank will have a completed mix just above this mark. So we'll fill it a little bit lower than that, mix in our product, which in this case will be 6 mLs. In your case, may be different depending on your calibration. And then we'll finish it out, agitate, and apply out the rest. Remember, at the end, when you're done applying, you will have residues in the tank. You will need to triple rinse and spray out in a manner consistent with the labeling. The easiest thing is to spray out the rinsate over the same area you just applied to, because any residual pesticides have already been calculated into your rate for that field. Thank you for watching, and please note that whether you're using conventional products, organic products, general use products, restricted use products. The process will be the same. It may seem daunting now, but once you're more familiar with your field areas and your equipment, it should get easier and easier and easier, especially as you get to know what products work for you over time. If you have any more questions, please contact your local extension office. And also, please check out the video links. We should have some information in there about good extension articles and contact information for your local area.